All right, welcome once again to our math workshop. We're going to be covering a number of different topics through our Jan 2024 past paper, right? I'm going to be doing solutions, and as I work through solutions, I'll just check to make sure that you guys understand how to complete these questions, and we'll see how far we can get in terms of getting this paper done and probably looking at another. All right, so first question. Expressed as a single fraction in its simplest form, right? 1 minus 1 over 30 plus 4 over 15. All right, so to begin with here, now we could do this on our calculator, but pay attention to the instructions. Sometimes they would say here, using a calculator, otherwise. They did not state this in this question, so I am going to go the route of working this out. Right, now I like to use equivalent fractions. So we have 1 over 30 here. If I could make this denominator 1530, I will do that to make it easier for me to work out this question. So I know 15 multiplied by 2 will give me 30. So that means I also need to multiply this 4 by 2, which will be 8, right? And that will give me 1 minus 1 plus 8 is going to give me 9 over 30, right? Now, a whole of 1 will be 30 over 30 minus 9 over 30. And now give me 21 over 30. Now, remember, they asked for this in the simplest form. So we need to reduce this fraction and we'll get 7 over 10. So my answer here for 2 marks is 7 over 10. All right, just give me a thumbs up if everybody's okay with that. Yeah. Good. So I'm moving on. A 2-story car park has a total of 1,020 parking spaces. At 6:30 hours one morning, 1/30th of the 1,020 spaces are filled. During the next hour, no cars left the car park, but another 4/15 of the 1,020 spaces are filled. Determine the number of parking spaces that are not filled. So between the hours of 6:30, right, for 1 hour to 7:30, we have a total of 1/30th by 1020 spaces being filled. Let's work out how much that will be. All right, so we could use 3 into this will give me 10, 3 into this will give me 3 with a remainder 1 there. That's going to be 40, and then 10 will go into this 1 time, and then 10 will go into this 34 times. So we're talking about 34 spaces being filled, right, during this period. So this is spaces filled. In the next hour, right, in the next hour, just a second, guys. Right. In the next hour, we have 4/15 of the other spaces being filled. So 4/15 by our, right, you could do 3 again. 3 into 15. Excuse, 3 into 15 is going to give me 5. 3 into this, we got 340 last time. And then 5 into 5 is 1. 5 here give me 6, 8. So we're going to get 68 by 4. And that's going to work out to be 240, 272 in total. Right, so total spaces filled it's 34 plus 272. That's going to give me 6, 10, 306. They want spaces that are not filled at 7:30 hours. right? So that's the next thing now we need to pay attention to, right? They're asking at 7:30 hours. So this is why I wanted to break this up. So at 7:30, which is at this point, the number of spaces not filled will be 1020 minus 34. Right, that's a total of 986 spaces not filled. Of the 1020 parking spaces, 20%, somebody's in the meeting room, 1 sec. 20% is in the top level, right? How many parking spaces are on the top level? So out of the 1020 parking spaces, 20% of all of these spaces are on the top level. So 20% multiplied by 1020. Now we should know our fractions for percentages. 20% is the same as 1/5. Right? And 1/5 of this is going to give me what? 204. So we're talking about 204 spaces on top level for 1 mark. Everybody okay so far? Just give me a thumbs up if you're okay so far. Yeah? Nice. So pressing forward, right? Some of the spaces are reserved for monthly paying customers. The ratio of reserved spaces to non-reserved spaces is 5:7. Calculate the number of non-reserved spaces. So the total number of spaces here, based on this ratio, is 5 plus 7, which is 11, right? Now, one part will be 1/11 multiplied by our 1020 spaces, right? And 1020 divided by 11 this here on the top level. Some of the spaces are reserved for monthly paying customers. The ratio of reserved spaces, sorry, the ratio of reserved spaces to non-reserved spaces is 5:7. That's a total of 12, not 11. So we're talking about the total number of spaces or the total number of parts in our ratio is 12. Anytime you have to work in ratios, you always add the ratios up together, and that tells you the number of equivalent parts. So we have a total of 12 parts. So if we divide the 120 spaces by 12, right, what we will get is how much is going to be equivalent to one part. So one part is 85 spaces. And what we have is 5 parts to 7 parts, where we have reserved being 5 and non-reserved being 7. So we are interested in the non-reserved spaces. So 7 multiplied by 85 is going to give me 7 by 85, 595. Non-reserved spaces. Is everybody okay with the ratios? Just give me a thumbs up if you understand that. Right? Not everybody, I only seen 3 hands up. Brittany, Eric, right. Eric said he doesn't. Let's look at another example. Eric, if we have 120 students in our class, and let's say we have a ratio of boys to girls being 4 boys to 8 girls. That's the ratio of boys to girls in the class. When we're working in ratios, what we will do is we will always add the number of parts up together. So the total number of parts here, if it's a 4:8 ratio, the total number of parts is going to be 4 plus 8. So that's 12. So we can write this as 4 twelfths and 8 twelfths if you want. Right? So the boys is 4 out of 12, which is all the children in the class. Right? This is students in the class. And the girls is 8 out of 12. Another way we could look at it is if we know that it's made up out of 12 parts, we could find how much students is one part. One part is going to be 120 divided by 12, right? Which is going to be 10 students. So if one part is 10 students, then 4 parts is going to be what? 40, and 8 parts is going to be 80. So 40 plus 80 is going to be 120. Shrizi, give me a thumbs up if everybody's okay with that. Eric, you all right with that now? Yeah? Karel? Jamari? Brianna? Brittany, we good? Eric, we okay? All right, nice. Good. But so the entire question is based on this parking lot, right? They said the cost of parking is shown in the table below. Michaela leaves the car park at 1830 hours. 1830 hours is 6:30 p.m. This is the time that she leaves. She pays $9.25. That's how much money she's paying for parking, right? Determine the earliest time she could arrive at the car park. Now, let's look at this, right? Now, she could arrive, she leaves at 18:30, right? Under 30 minutes is free. 30 minutes and up to 2 hours is $2.25, right? More than 2 hours and up to 4 hours is $5.50. And look at this, more than 4 hours and up to 8 hours is $9.25. So this is the amount that she paid. Agree with that? Everybody give me a thumbs up if you agree with that. Now let's look at the range. In order to pay this amount of money, you have to stay in the car park more than 4 hours. So you could stay in the car park anywhere 4 hours and greater. Up to, there's a point, there's a limit, up to 8 hours. Up to 8 hours. So the earliest that she could arrive in the car park will have to be on this end. She could have arrived in the car park 8 hours before 6:30. That's the earliest she could have gotten there, right? The latest would have been probably 4 hours and 1 minute, right? Because you will be charged $9.25 if you are there more than an hour. Everybody understand that? Earliest, it means that you've used the entire 8 hours. So let's go backwards, right? So I like to use a timeline when I'm doing time. It's easier to see that way, right? So let's do 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, 6, 7, 8 hours. So let's check that. So at 1 hour, 1 hour before 6:30 is going to be 5:30, then 4:30, then 3:30, then 2:30, 1:30, right? This is going to be 12:30 in the morning, well, 12:30 p.m. still, then 11:30 a.m., and then 10:30. So the earliest time she could have arrived at the car park would have been 10:30 a.m. Everybody okay with that? Everybody agree with that? Everybody understand the timeline? Just give me a thumbs up if you do. Good. Jamari, Shaniqua, you okay? I know you just joining. Joshua, Eric. Okay, good. Danraj bought a weekly paying ticket for $40. That week he visited the car park 5 different times. The length of time he parked his car on each occasion is given below. So let's make a little table. We have 25 minutes and we're gonna look at the charge for each of these, right? Right, so just make sure your mic muted, okay? Then we have 7.5 hours. We have 11 hours. We have 8.75 hours. And we have 8 hours. So what I'll do is I'm just gonna cut out our table so we could have it right next to our question so we could just easily look at it. Right. So under 25 minutes, under 30 minutes, sorry, is free. Right? 7.5 hours. So 7.5 hours would fall inside of here, right? That's more than 4, less than 8. So that's 9.25. Right? Then we have 11 hours. 11 hours would fall in this category here. 8 hours to 24 hours. That's $15. Right? 8.75 hours will also fall inside of here. Right? And then we have up to 8 hours, 4 hours, and up to 8 hours is 9.25. Let's check that up. So we have 9.25 plus 15 plus another 15 plus 9.25. That's a total of 48.50. Now let's compare that against a 1-week ticket. A 1-week ticket is flat $40. So he could have saved $48.50 minus 40, $8.50 if he purchased a 1-week ticket. Everybody okay with that? Give me a thumbs up if you're all right with this one. Good. Now, with these first set of questions, when you're doing this in your paper, right, although it's not very difficult, you need to take your time and read the question. Notice what I did. In certain instances, I circled numbers. I underlined things. So I made sure that I understood what the question was asking, right? You do not want to lose any of the marks here. None, right? You don't want to lose any. You want to capitalize and earn in as many marks, as possible in section 1 of your paper, especially at question number 1. You don't want to lose marks there. So make sure and read the questions thoroughly, especially those worded questions. And don't be presumptuous and assume that you know what they're going to be asking. Double check your working. All right? Okay. So is everybody good with question 1? Could I get thumbs up if you're okay with question 1? I'm going to move on to question 2 now. Anybody have any questions at all on the first question? Jamari, Joshua, Brittany, anybody? No? All right, so I'm going to move on to question 2 now, all right? So question 2 usually looks at algebra, right? Simplification. Now here we have x squared plus 7x. On top here in the numerator, we could see that there's a term that is common between these two, which is the x. So simplify means that we could also factorize in order to write something in a simpler form. So I am going to write this as x into x plus 7. Why? Because x squared and x has a common factor, which is x. I am dividing x squared by x in order to get what I'm putting in the bracket here. And I'm also dividing 7x by x in order to get this here. All right, so this is what I'm getting the contents of my bracket. X squared minus 49. This is an example of a perfect square. So, not perfect square, the difference of two squares. Difference of two squares. How could we identify the difference of two squares? Well, the difference of two squares is first distinguishable by that minus sign that you have between the two numbers, right? So the first thing we need to look for is the minus sign. The second thing, the other things has to be two perfect squares. What is a perfect square? A perfect square is any number that when you find the square root of it, you're going to return a non-decimal number. So for example, or a whole number if you want to call it that, this will give me 7. Square root of 25 is going to give me 5. Square root of 36 is going to give me 6. 49, 25, 36, they're all perfect squares because if we look at repeated multiplication, 7 by 7 is going to give me 49. The same thing happens for the letters. The square root of x squared is going to return x. Repeated multiplication. So this is also a perfect square. Y squared, perfect square, right? Most letters squared will be a perfect square. All right. Now, once you have identified that the minus sign and the two perfect squares, to factorize, listen to this, to factorize perfect squares, we are going to write two brackets. In one bracket, we're going to put a minus sign, the other we're going to put a positive sign. And then we're going to find the square root of these perfect squares. The square root of x squared is x. The square root of 49 is 7. And you're repeating that in both brackets. That's how you factorize a difference of two squares. Give me a thumbs up if you understand that. Good. Now look at the next step. The next step is we could cancel this bracket here with this bracket here. The reason we could do that is because we are multiplying here. If this was x plus 7, we cannot cancel like this. That will be wrong. The reason is because of this plus sign. Because of that plus sign, had it been a plus sign, we have to treat this entire thing as one term. So we cannot cancel one part of the term. We could only cancel the entire thing, right? So we must have something that matches both of these in order to cancel. All right, always remember that, right? So only because on top is we have multiplication taking place here, x into x plus 7, we can now cancel these two brackets. Okay, everybody understand that? So we will remain with x over negative 7. Everybody understand this question? Give me a thumbs up if you understand this question, the solution to this question. Rihanna, we good? Karel, we good? Joshua? Jamari, we all right? Joshua, we good there, right? Nice. Good. Find the value of r. Now on this side here, we are multiplying x squared multiplied by x to the power of, that looks like a 6. Now, because these bases are the same, because these letters are the same, we can add the powers on top. Only because they are the same. So R is equal to 8. If those letters were not the same, for example, if we had x to the power of 3 multiplied by y to the power of 5, you cannot add the powers here. You will just write these two letters next to each other with their respective powers. All right, so you could only add the powers when we are multiplying and the bases are the same. Everybody all right with that? Good. Next question. S to the power of 3 is equal to 8. They want to know the value of S, right? Now we could move this power across the equal sign. It becomes the cube root of 8, right? Just like if we had S squared is equal to 4. If we want to find what S is, we'll find the square root of 4. Same thing happens here, except we find the cube root. Cube root of 8 is 2. 2 multiplied by 2 multiplied by 2 will give me 8. So the value of S is 2 for 1 mark. All right, give me a thumbs up if you're okay, and we can move on. Good. All right, so moving on to the next question. The diagrams below shows a triangle and a quadrilateral. All angles and degrees are written in terms of A and or B. Now, the sum of the angles in a triangle, sum of angles in a triangle is equal to 180 degrees. Sum of angles in a quadrilateral is equal to 360. We need to use this property in order to work out our following two questions. They're saying here to show that 2a plus 5b is equal to 171. Do not let the numbers or letters here in this question intimidate you, right? All it simply means is that if we add this angle, and this angle, it should be equal to 180. And we could do that. Let's try. A plus 2b plus b plus a plus 9. We add up all those angles, it should be equivalent to 180 degrees. Now, when you're simplifying expressions, I suggest underlining similar terms. So a and a is 2a. Then I could do the b's. That's 3b. And then this 9, right, is not a variable. I just could move across here to work out with this 180. 180 minus 9. So I'm going to get 2a plus 3b, and 180 minus 9 is 171. Did I miss something? Oh, this is a 3b here. My bad. 3b. So we have 5b's here. Everybody okay with this one? Give me a thumbs up if you understood that. Raise your hand if you want me to just do it another time. Sure. So I'll write it over, okay? Right. So we go in, we use any property that the sums of an angle and sum of angles in a triangle is 180. So basically this angle plus this angle plus this angle if I add all of these up, 3b plus a plus 2b plus a plus 9, those are the triangles. All of them added together is 180. Like terms, a plus a is 2 a's. b, 3b plus 2b is 5b. 9 has to go across here to work out to the 180. 180 minus 9, because when I carry it across, it becomes negative, is going to give me 171. You all right to that, Eric Solano? Jasmine? Everybody right? Same thing happening for the other question. We're using the property of quadrilateral. Sum of angles in our quadrilateral is 360. So this angle plus this angle plus this angle plus this angle, 4 angles in all. If I add each one of them up, it's going to be equal to 360, right? Definitely. So we have 6a plus 3a plus 2b, right? All right, and now each of them as are going around. Plus 3b minus 2a plus 18 plus 3b, right? Each of them are writing out is equal to 360. Now, when you have all of these terms mixed up, jumbled up together, write all your a's together so it's easy to work them out. 6a plus 3a, right? Underline them. Make sure take the sign in front of it. Minus 2a. Then do the b's. Plus 2b plus 3b plus another 3b. And then what you left with here? 18. Carry that across on the side. 360 minus 18. You work these out. 6a plus 3a, that's 9a's. And 9 take away 2 going to give me 7a. And then 2b plus 3b, that's 5. Plus another 3, that's 8b's. And then 360 minus 18 is going to give me 342. Give me a thumbs up if you're okay with that. Right? Not too difficult. Now, again, I'm reiterating this. You see how many 1-mark questions they have there? But every time we leave one of these marks on the table, we are making it difficult for us to make up a larger proportion of marks in our paper too. Attempt all questions. Do not leave anything blank. Sometimes, even if it is, you might get the incorrect answer and the examiner could see that you was on the correct track in terms of your trend of thinking, your thought, your logic. You will still be able to earn a half mark here and there. And the marks add up. The marks add up for everyone you earn, and it also adds up for everyone that you leave out. So don't cheat yourself out of marks. Right. So next question. Is a simultaneous equation. I just need to mix up with it. Solve the pair of simultaneous equations. So look at what we have, right? We have 2a plus 5b is equal to 171. 7a plus 8b is equal to 342. All right. So look at this, right? There are 2 ways to do simultaneous equations. There's the elimination method, and there's something called the substitution method. I'll show you the difference between both of them. Here, we need to use the elimination method. If I had something like x plus 2y is equal to 10 and 2x plus 3y is equal to 5, here I could use the substitution method. How do you know when to use the elimination versus when to use the substitution? Well, the substitution method, or the key, or what is the hint, or what's supposed to enlighten us to, all right, I could use substitution method here, is anytime you see a lone x or a lone y, or any lone variable, meaning that you see an x by itself, a y by itself, a letter on the whole by itself. Anytime you see that happening, you take that letter and you make that letter the subject of the formula. So to make x the subject of the formula, I could take y and move it across here. So it becomes x is equal to 10 minus 2y. Now that I've done that and I've made x the subject of the formula, this is why we call it substitution method. We can now substitute for x. Whoops, what is that? We can now substitute for x 10 minus 2y, because we are saying here that x is equal to 10 minus 2y. So anywhere I see x, I can put 10 minus 2y. And guess what I was going to do? We have just substituted here for x 10 minus 2y, and by doing that, we now have an equation where there's only one unknown, meaning that there's no more x's and y's, but only y. So we could solve for y here. Right, we get 20 minus 5. I'll carry the y on this side to make it positive. I'll carry the 5 here to make it negative. And 20 minus 5 is 15. I could solve for y, and then I could go and find out what x is here by taking x is equal to 10 minus 2y and subbing that 15 inside of here now. This tends to be the easier method. If you could find two simultaneous equations where you have a lone term, I call it a lone term, you know, like the Lone Ranger moving by itself, right? That's a lone x or a lone y, like a cowboy, right? Everybody understand that? The more thumbs up if you understand that. Hands up if you don't. Anybody don't understand it? Joshua, we good? Eric, Kirel, Jamari. Right. So everybody understand that. Unfortunately, for this question, we don't have any lone values. There's a 2 in front of the A, a 7 in front of the A 5 in front of the B, a 8 in front of the B. So we can't use that method here. We now have to use the elimination method. Now, how the elimination method works is that we want to try to make now, to choose any letter, I'm going to choose A. We want to try to make the coefficients in front of A the same. To do that, we would usually have to find the LCM of the two numbers. What is the smallest number that 2 and 7 could go into? That would be 14, right? Usually you can multiply the two numbers and you should get the lowest common multiple. So to make 2 14, I will have to multiply 2 by 7. But it means that I am multiplying the entire equation by 7. So what I will get is 14A plus 35B, and 171 by 7 is 1197. This is a new equation. I'll call this equation 3. We'll practice it. I'm going to fix that. The more thumbs up if you understood what happened there. Thumbs up if you're okay with that. Everybody understand that, right? I multiply the whole thing by 7, and I get 14A, 35B, 1197. And I get a whole new equation and I call it that 3. Okay, now, remember we want to make the two A's have the same coefficient, the same number in front of it. So to turn this 7 into a 14, I have to multiply by 2. But when I multiply the entire equation by 2, while I will get the 14A, 8 is going to multiply by 2 and become 16B. And 342 is going to multiply by 2 and become 684. And this is another equation 4. By doing this, I could eliminate A, hence the name elimination method. Why? 14A minus 14A will give me no A's. It'll be eliminated. We get 0. Now, this is the tricky part where a lot of students tend to make a mistake. Remember, this is 35B minus 16B. Pay attention to your signs. If this was a minus sign here, then it will become 35B minus 16B. And a minus by minus will become a plus. Luckily for us, this is a plus sign here. So it will be 35 minus 16. So we're going to get 19B. And we get 1197 minus 684. That's 513. To find out the value of B now, we will divide 513 by 19. And that works out to be 27. Now we're not done yet. This is just B. So we have to find A now. So I'm going to use 2A, substitute B to be 27 in 2A plus 5B is equal to 171. So I get 2A plus 5 by 27 is equal to 171. Right? 5 by 27 is 135. So this 135, we're going to move across the equal sign. We get 171 minus 155. That's 36. So A is equal to 36 divided by 2. So A is equal to 18. Me, I always like to write this back for them so they could see that I found the value of A and B. Everybody good so far? My thumbs up there if everybody good so far. Good. All right, so this other question. We was required to draw this triangle, right? They gave us AB and they asked you to copy it in your book. Now you had to use your ruler and your compasses to do this, right? Now what you're doing is you're taking your, I'll show you, right? So it's really difficult to do this kind of question. This is my ruler here. They say that that line AC is 8 centimeters. No, wait. The line AB has been drawn for you. Oh. So Well, you'll be writing on the paper, right? Remember, for the maths paper, just like how you see this here, you're writing on the paper. So the line AC now, C is our next point. If you look at my diagram here, C is our next point away from A and B, right? So AC is 8 centimeters. All you're doing is you're taking the ruler, you're watching where 0 is, where 8 centimeters is. This will be my compass. Let's have my stationery in here. Son on my daughter, I don't know who's coming. I'm just taking all of my stuff here. Try and stick more pen from more tablets in it. No, that can't fit. Right? We'll use this. Basically, what you're doing is you're opening the compass to 8 centimeters, right? So one point of the compass, everybody can see this. I want to put on the 8 and the other point on the 0. So that this itself here measuring 8 centimeters. Everybody understand now? More thumbs up if you understand now. Good. You're then going to put the point of the compass. You're going to put this point of the compass on A. So the point of the compass resting here. And then when you rest the compass here now, you're just going to scribe like that. You're going to hold it up. And what you'll do is when you scribe, you're going to make this little line here. That's what I mean by scribe. So basically, the distance from here to here is going to be that 8 centimeters. Why? Because I open the compass to 8 centimeters. Everybody can visualize that. See me putting it on the paper there and just making that line with it like that. Just give me a thumbs up if you understand that. Makes sense, right? Jamari, you good? Joshua, Kirel, Solana, you understand that, right? You understand the point to opening the compass to 8 centimeters?
Yes, sir.
Right.
Like you have a line and they ask you to stretch like a 60-degree angle. A subtitle like adjust. Kind of
Right. So it have no setting. You just need to open it to one size. And after you open it to that size, you don't change it. There's no, I just need to open it because when I constructing the angle, what I'll do, right, is, I don't know if I could find now, boy. I'll have to go and check in more Google Drive and see if I could find just now. I do a video years ago for some students on constructing angles videos, WhatsApp videos. I was on a totally different phone. Had an iPhone there, so I would look and see if I find out face around. If not, I'll just have to make over video for you all. We are constructing the angles. 2018. I might just have to make over video for it, right? But I'll find someone sent it. This question though, Solana, it have no angles to construct. Here we just simply opening the compass to 8 centimeters, making that scribe, And then you're gonna change this now to 5 centimeters. So you adjust this to 5 centimeters now, but now you're putting the point on B. And you're gonna scribe. Where the two of them make a X, you're just gonna take a ruler now and connect from A to C and connect from B to C. So no angles here was constructed. The second part was to take your compass, your protractor now. The protractor is a semicircle thing. You're making sure that there's a little point on the compass here, and there's a line at the bottom. You want to make sure that the line is resting on this line AB, and that this little point or the little stroke, the halfway point, is on A. And then you're going to look for where your line AC now is passing through. Remember, on this side, going to have all of the degrees on the protractor. And you realize that it's passing through 40. And that's how you're measuring this angle. Everybody understand that? So in this question, there was no need to construct the angle, right? You can't construct a 40-degree angle that easily anyway, right? There are three basic angles, well, four basic angles. There's 90 degrees, right? There's 120 degrees, there's 60 degrees, there's 30 degrees, and there's I tell you 120 already, right? 30, 60, 120, 90, and 45. Those are the four main angles that we can construct, but at least what we will construct at the CXC level. Those are the angles that I will demonstrate. I'll do it on a video and send it for you. Real easy to do. Everybody okay with this question? Can I move on? Give me a thumbs up.
Yes,
yeah? Right, the diagram below shows an equilateral triangle. In an equilateral triangle, all sides and all angles are equal. All sides, all angles are equal. So if here is 13, it means here is also 13, here is also 13. It means that this angle, and the whole angle on top of here is equal. So if we have 180 degrees in a triangle, and we say we have three equal angles, what is the size of each angle? Very good. So that means that this angle here is 60 degrees. This angle here is 60 degrees. And up here, this angle here will be split in half, will be 30 and 30. Everybody agree with that? Good. Now, they ask us to find the height of this triangle. So if we have, my maths teacher always used to tell us, when we have these type of questions, it's good to draw over the triangle that you're working with. It's easier for you to see what you're doing, and it helps the examiner to see that you know what you're doing. So this is 60 degrees, right? Now, this line here, the height, is a perpendicular line that's going to divide this base into two equal parts. And half of 13 is going to be 6.5 and 6.5. Everybody agrees with that? Yes?
Yes, sir.
Good. So I have this half of the triangle here. I'm going to call this other point M for now, right? And I want to find the height, H. I could use my knowledge of trigonometry in order to work this out. Now, we know that when we have to do trigonometry, the first thing that we need to do is label the triangle. Always label a triangle first. So this is the line that is opposite the 90-degree angle, which is also the longest line in triangle, is always a hypotenuse. The line that is opposite the angle that you are working with. I am working with a 60-degree angle. So the side that is opposite that is the opposite. And well, this will have to be the adjacent, right? 1 second, right, guys? Right, so we said the first step was to label the triangle, right? Which I did. So hypotenuse, opposite, and adjacent. I will then state what I have. State what is given. That's what my maths teacher used to make us do. Mr. I can't say state what is given. So we have the angle, 60 degrees. $60 is the angle. My adjacent is 6.5 centimeters. The next thing I want to do is what I must find. I want to find my opposite, which is that H that they're talking about, right? Now let's look at the sides that we're talking about there. We're talking about adjacent A and an opposite O. Let us write so, ka, twa. Opposite is a O, adjacent is a A. I'm looking for one of these that have O and A in it. This have a O but no A. This have a A but no O. So that means that I have to use tan. So use tan ratio. Write my formula. Tan theta is opposite over adjacent. I'm going to substitute my values now. The theta we say was 60. The opposite is the H that we're trying to find, and the adjacent is 6.5 centimeters. So if I want to find H, I need to move this 6.5 across here, right? So I'll get tan 60 multiplied by 6.5. Let's work that out. So tan 60 multiplied by 6.5. That's going to give me 11.25. Centimeters, and I could say to 2 decimal places. Everybody okay with that? Give me a thumbs up if you're all right with that. Brittany, Rihanna, we good? Jamari, Joshua, Eric, good too. Nice. All right, so remember those steps. If you practice doing it like this, any question they bring, it'll be easy for you to identify what size you have and what you need to find. These two are the key to determining which one of these formulas that you want to use. Right? The sides that is given and the sides that you have to find is going to help you to determine which formula you want to use. Notice here that we said, all right, we know what the adjacent is. We want to find the opposite. So that means I have to look for a formula that has both opposite and adjacent in it. And I go through an elimination process. I check so, that has the O but no A. I check ka, that has the A but no O. So that means I am left with tan, which has both O and A. I quote the formula. So that way now visually I could see, all right, tan theta is equal to opposite over adjacent. So I could now substitute the values that I have inside of that formula in order to solve it. Okay? Good. I'm moving on. Part C now. The diagram below shows 3 triangles. P, Q, and R. The triangles Q and R are images of triangle P. So this is the original here. Images of triangle P. So this is the object. And these two are other images. After it undergoes a double transformation. Now, different types of transformations could include things like a reflection, a rotation, and what we call a translation. Another word for translation is a shift. You take something here and you shift it across here. So the points change. Rotation, well, you know rotation. Spin it around a certain amount of degrees. You can turn it 90 degrees, 180, 270, 360, or even a weird degree inside there, 45. Reflection, like a mirror. It's a mirror image. So certain properties remain the same. The distance away from the mirror line is going to be the same, right? So those are the three main transformations that you are always trying to describe in these type of questions. Give me a thumbs up if you understand that. Describe fully the single transformation that maps triangle P onto triangle R. So we're talking about these two here, right? Now, you could look at them and you could tell if something is rotated, then the points are going to be in a different orientation, right? If you look at this is still here and this is still here, right? Meaning that the orientation of the triangle didn't change. It's not looking like this now, right? This original triangle is still, if I take it and put it on top of this, it's still looking the same. But if I take this triangle and try to put it on this, you'd realize that these 2 points are on opposite sides. So that in itself tells me that something more has happened. This could look like a shift. Look at it. It shifted up this way. Everybody could see that? It didn't rotate. It's clearly not a reflection, right? Because if it's a reflection, it would be like the opposite of it. Agreed? Everybody agree with that? It looked more like a shift. Brittany, Brianna, Solana, see now? Looking like a shift. I can take it and I just slide it up on top. Does it look like that to you? No, Solana? Jasmine? You all there with me? Jasmine say, all right, good. So I would say that P onto a triangle R is a translation, sorry. And how we could determine if something was translated? Well, I'll show you I could prove it. So you have to have a little suspicion first, and then you have to find something to support your suspicion. Let's look at the points. This point here is the point 1, right? So here, this point I'm talking about by, right? That's the point 1 on my X and -2 on the Y. Right? This point here is the point 2 on the X and -3 on the Y. This point here is the point 1 on the X and 0 on the Y. Right? So let's look at those points. We have 1, 0. We have 2, -3. And we have 1, -2. Right? This is my object. Now let's look at the image. This point here, right, which will correspond to the 2, -3. Look at the triangle, right? That point there is the point 4, 1. 4, 1. No. I'm gonna start from the top. I'll label all the points first. So this point here is the point 3, because here will be 3, and this is 4 here. But you agree with that, right? This point is going to be 3, 2. And we already record this to be 4, 1. So starting from the top of the triangle, just like how we start from the top here. This is 3, 4. This one here is 3, 2. And this one underneath here now is 4, 1. Let's subtract these points and see what happens. 3 take away 1, going to give me 2. 4 take away 0, going to give me 4. Right? This one is, I have these in different pieces. Right? This 2 negative 3 is with this 4, 1. And this 1 negative 2 is this point here, 3, 2, right? So 4 take away 2 is going to give me 2. And 1 minus 3 is going to give me 4. Here we have 3 take away 1 to give me 2. And 2 minus 2 to give me 4. What you notice about the answers for the difference between the points on the object and the points on the image? They all have the same. This word here is our translation vector. So we could compare the points. If we subtract the points on the triangle in the image, or we take the points of the object away from the image, and we are getting consistent values, it means that the entire shape has been shifted. Let me show you how. Let's look at each of these points, right? And this might help you understand. Look at this point. This point was shifted 2 times this way. Watch it. 2 times this way, right? You agree with that? Give me a thumbs up if you agree with that. From here to where it is now was 2 moves in a horizontal direction. Everybody, give me a thumbs up if you could see that. The point here and it moved to here. That's 2 blocks moving this way. Everybody see that? Thumbs up if you see that. Yeah, Shaniqua, Solana, Jasmine, Joshua. You good, right? Good. So that's this movement now we're talking about there, right? So that's 2 blocks to the right. And then we went 2 blocks to the right. And then how much blocks we went up? 1, 2, 3, 4 blocks up. That's just 4 blocks up here. Let's look at this point. This point went 1, 2 here. See now? Look at where it went. 2 blocks this way. And then 1, 2, 3, 4 blocks up. Everybody see now 1, 2? 2 blocks up, 4 blocks. 2 blocks across, 4 blocks up. Same thing with this one. 2 blocks this way. And then 4 blocks going up this way. Everybody see now? So this shape was shifted, all the points shifted 2 blocks across and 4 blocks upwards. Everybody agree with that? Give me thumbs up if you understand now. No. Good. Excellent. Right. So let's answer the next part of the question now. Right. Next part of the question, looking at this triangle with this triangle. Now you can tell when it's a reflection. because it looks like it's inverted on the opposite side. Like you take it and you flip it across. When I look at this, I suspect a reflection, but how would I know it's a reflection? Well, I need to look at the space in between the points. Usually it's very even, right? Look at that. I check in 1, 2, 3, 4 blocks, right? So let's see if there's a mirror line happening there. All the points is going to be equally spaced away from each other. Look at this. This has 2 on this side, 2 on this side. Look at this point. 2 on this side, 2 on this side. Look at this one. 3 on this side, 3 on this side. So we could clearly see that R is being reflected in this line here. What is this line? This line is passing through the point 1 on my x-axis. So R is being reflected in the line x is equal to 1. X is equal to 1 is that vertical line that's passing through the point 1. You okay now? So with these type of questions, it's a looking and observing type of game, and then you need to confirm the things that you are suspecting. All right? Everybody understand that? Are we okay with this question? Give me a thumbs up if you're okay and we can move on. Everybody, Shaniqua, Solana, Jamari, Kirel, Tariq, Joshua, Eric, Brittany. Solana, we all right? Brittany, we good? Nice. Brittany, we all right? We could go on? All right, nice. All right, next question now. All right. So this question, we have f of 4, right? Remember, those of you that was with me last week, functions is all substitution. If I say f of 4, it means that wherever I have x, I am replacing that x with a 4. So this is going to be 2 minus 5, open brackets, 4. And then I work it out. 2 minus 5 by 4 will give me negative 20. And 2 minus 20 is minus 18. H of 0. Wherever I have x, I'm replacing with a 0. 5 to the power 0 is going to give me 1. This is what we call a composite function, and we need to do it in parts. So first we can work out what is h of negative 2. H of negative 2 means that up here I'm going to put a minus 2. And when we have something raised to a minus power, we write it as a fraction, and we put the square here in the denominator. We put the number in the denominator. So this is actually 1 over 25. Now that we know that h of negative 2 is 1 over 25, we could rewrite this, and instead of putting h of negative 2 here, we could put the value of it, which is 1 over 25. Remember we said functions is all about substitution. So wherever I had the x, remember we had the x here before, I am going to replace this x with 1 over 25. So what will I get? We could cancel. 5 will cancel with this, and I'll get 5. I'll get 1 here. So I'll get 2 minus a fifth. And 2 minus a fifth, 2 is like 10 over 5, right? Everybody understand how I get 10 over 5? I just multiply 2 by 5 to get 10. If I reduce that, I'll get 2. And 10 minus 1, this is a 5 on it here, it's going to give me 9 over 5. So f or h on negative 2 is 9 over 5. Everybody understand that? Give me a thumbs up if you understand that. Very good. So we're pressing forward, right? They want us to find f inverse of x. So remember our steps. Let's write f of x. F of x is equal to 2 minus 5x. Our next step is to replace f of x with a y. Next step is to interchange positions. So wherever we have x, we write a y. Wherever we have y, we write a x. Wherever we have a x, we write a y. Then we're going to make y the subject. So I'm going to move this 2 here. Becomes negative 2. Then I'm going to move this 5 here. But it means I have to divide all of this by negative 5. This is my inverse of x. X minus 2 over negative 5. Okay? They want f of x. So f of x we know is 2 minus 5x. So it means that wherever we have the x, we want to put this whole thing called 2 minus 5x in there. And that's going to give us negative 5 by 2 will give me negative 10. Negative 5 by negative 5x will give me positive 25x. So I will get negative 8 plus 25x. So A is negative 8, that's this A here. And B is 25 as this value in front of the x. Understand? So these composite functions, it's a function of a function. So you're replacing this f of x with what it is, which is 2 minus 5x. And then I will substitute this entire 2 minus 5x inside of here. This is where x was. Remember, f of x is equal to 2 minus 5x. Everybody all right with that? Yeah? Okay. Statistics time now. The mass M in kilograms of 120 newborns at a hospital is recorded in the table below. So think about this as a group distribution, meaning that you have 120 newborn babies. You're not going to sit down and write out each individual weight. So to make life easier, you say, well, all right, let you see how much babies weighing in between 2.6 kgs and 3.5 kgs. How much weighing between 3.5 and 4.4. How much weighing between 4.5 and 5.3, and like that, you're going down the line. So it have 7 babies that falling in between these weights. That's a class in itself. So they are babies in a class 2.6 to 3.5. Then it have 18 of them now inside of this, 30 inside of this, 29 inside of this, 28 inside of this, and 8 inside of that. Everybody understand now? If we add up all of these, it's going to add up to our 120 newborn babies. Now this is a not easier, but a more structured way of collating the information for 120 newborns as opposed to writing out 120 weights. Raise your hand if you agree with that. Nobody agree with that? Or you rather write out 120 weights? Give me a thumbs up if that makes sense. If you was given a job to write out the weights of 120 newborn babies, wouldn't it make sense? Because you might have 7 babies within 2.6 and 3.5. Somebody might be a 2.7, and next man is a 2.9, and next one is a 3.1, right? So instead of going and write all those things, you say, all right, it has 7 of them in between 2.6 and 3.5. It has 18 of them between the weight of 3.5 and 4.4. Right? Raise your hand if you understand what I'm saying there. Everybody, Jamari, Brianna, Kirel, Eric. But they're tired though. Jasmine, that thumbs up is that you're tired or you understand? Let me push you, let me fight up a little bit again so we could get tired. There's plenty. All right. All right, raise your hand if you want a little 5 minutes. So you stretch your legs, grab some water. I can rest my throat a little bit. Check out hands. Tariq say yeah. Brittany, you too? Brianna? Yeah, Brittany is on. All right. All right. Take out 5 minutes because we're jamming since what, 11:30? So they do what? 11:30, 12:30. All right, cool. We meet them back for 1:15, right? Because I had to wrap up at 2:30 because I have an appointment after. So I'm already trying to see if I could finish the wood paper before 2:30. Because tomorrow is Mother's Day and my wife wouldn't forgive me if I put class for tomorrow. All right, so 1:15, and then we come back and see what we could do in the paper again. All right? All right, 1:15. Right, so I was explaining the concept of the frequency distribution table, right? Which I think is important. I have a gut feeling that you'd see something like this on the paper. Basically, what it does is it looks at a set of data. So here they're recording the weight of newborn babies in a hospital. And what you're doing, instead of having to write out the weights of 120 individual babies, we are creating these groups that we call class, right? So you have, instead of 120 weights, we have what, 6 classes or 6 groups, right? And we would create this based on the weights that we are seeing. We're seeing that babies weigh as little as 2.6 kgs to as much as 80 kgs. That's 8.0. That's a mistake they have there. Right? Can never weigh 80 kgs. Right? So that's the range of values. The lowest value being 2.6, the highest value being 8.0. And then inside of there, we have broken it up into groups. So there's one group that looks at babies between the weight of 2.6 to 3.5. Then another one that looks at greater than 3.5 to 4.4. Then greater than 4.4 to 5.3. Greater than 5.3 to 6.2. Greater than 6.2 to 7.1. And then between 7.1 and 8. Now, all of the babies that we have weights for fall into those different categories. And this table is telling us the number of babies that is inside of each category. So for example, babies with the weights of 4.4 to 5.3, the number of babies with that weight is 30. There are 30 babies inside of that class or that category. Ironically, I chose that class because this question here asks us to state the modal class. So mean, when we talk about the mean, we're talking about the average. When we talk about the median, we're talking about the middle position. And then when we talk about the mode or modal, we're talking about the most frequent occurrence. So the most amount of babies belong to the class of 4.4, greater than 4.4, and less than or equal to 5.3. That's where you have the most frequent weights in that class. All right, so that's for 1 mark. Now, this table is a nice table for you to understand because this is how basically you calculate your values to do a cumulative frequency graph. You are usually given the class. You are then asked to find the midpoint. The midpoint is found by taking the end points of the class adding them together and dividing by 2. So if you go on a calculator right now and you do 2.6 plus 3.5, and then you divide that by 2, you will get 3.05, right? So quickly, take 5.3, add it to 6.2. And divide that by 2, and somebody tell me what you get. And somebody else do 7.1, add that to 8, divide that by 2, and tell me what you get. 8.4, very good, Tony. 8.4 is a chart. This one, right? First one, good. 8.4. And last one, anybody? That's like what, 15.1 divided by 2. 7.55. Right? So the midpoint is usually labeled our X. The frequency, we had that from above, right? That's the number of babies in each class. We then multiply the frequency by the midpoint. So we multiplying across here, 3.05 by 7, 3.95 by 18, and like that, right? So let's do our 8.4 by 29. That is going to give us 243.6. And then this is going to give us 7.55 by 8, 60.4. Right, so this is going to give us our f by x, or f of x. Right, well, not f of x, but fx. Right, is now function. We would usually find the total of this column. This is the sum of fx. Right, that's what we call this. So we're adding up these things here. Now you need to do this. This table is going to help you work out what the mean is. 21.35 plus 71.1 plus 145.5 plus 243.6 plus 186.2 plus 60.4. That's going to work out to be 728.15. So this E here means the sum of fx, all of these things is 728.15. Now, when you have to find the mean of data that is arranged like this, we always have to work out what the sum of f of x is, and then divide it by the sum of f. The sum of f is the total of this column, which is the 120 babies. We always have to work out what this column is by finding the midpoint of the classes and multiplying by the frequency. Right? This is helping us work out our average. Remember, we say it have 7 babies in this class, 26 to 3.5. But it have varying weights inside of that class. So the easiest way is to find an average weight of babies in that class. So we add the 2.6 and the 3.5, divide that by 2. So the average weight of a baby inside of that class is about 3.05. And you have 7 of them. So the total weight of all the babies in that class is 21.35. We do that for all of the classes. So that's going to give us an average weight basically of all of the babies, all 120. And then we divide that by 120 to find out the average weight of all the babies. Give me a thumbs up if you understand that. That makes sense there, right? So this is why we need this table, because we're not adding up all 120 weights. We cannot using a guesstimation, if you want to call it that. So this is going to give us 6.07 kgs. So we have estimated the mean mass of the 120 newborn babies. Everybody right with that? Good. Next part. Now, one newborn baby is chosen at random from the hospital. Find the probability, right, that the newborn has a mass greater than 5.3. Now, probability is always the number probability mass greater than 5.3 is the number of successful outcomes. A successful outcome would be a baby that has a mass greater than 5.3 over the number of total outcomes. So they only have 120 babies, right? So let's go back to our chart. Greater than 5.3. So from here, this class says the mass is more than 5.3. So we have 29 babies here. This would also be greater than 5.3 because this is 6.2 to 7.1. And this is also greater than 5.3 because this is 7.1 to 8. So 29 plus 28 plus 8. 29 plus 28 plus 8 is 65. 29 plus 28 plus 8 over 120 is 65 over 120. If we divide 65 by 120, you will get 0.5416. Just leave it at 0.54, right? And if you multiply this by 100 to get the percentage, you get 54%. So at any random given time, if I pull a weight, there's a 54% chance that that baby is more than 5.3 kilograms. More thumbs up if you understand that. Tony, Tariq, Solana, Eric, Brittany, Kirill. Yeah? Okay. Cumulative frequency now. All right. So I need my cumulative frequency column. I need my frequency column. So I'm cutting this out from here, right? Now, ideally, what happening here is that 7 plus 18 is 25. 25 plus 30 is 55. 55 plus 29, right? It's like a running sum, right? They're adding up, and as they add up, they keep adding more numbers till they reach to the 120. So 55 plus 29, that's 84 here now. Then adding the numbers from the next group here. 84 and 28 is 112. 112 and 8, 120. Now, when we have to draw a cumulative frequency curve, a cumulative frequency curve, you have to take your upper class boundaries or your upper class limit, right? Any one out of the two. Here they use any limit. If you go back to the table, look at this. This is the upper limits of each class. See that? 3.5, 4.4, 5.3, 6.2, 7.1. They take those upper boundaries, upper limits, and they are plotting that. I wasn't supposed to use that. Right. And they are plotting that against the cumulative frequency. So let's look at the graph. The graph is the next question. The cumulative frequency always goes on the y-axis. right? And the mass, whatever they measuring, will go on the X. So you see how they plotting it? 2.5 and 0, right? 2.5 will go with 0 because that's below the 2.6. It have nobody in that group, so it's starting from there. And then 3.5, and look at what we had in our thing, 7. So you see, this is roughly about 7 there because you're counting in twos, right? And you continue like that. Let us take our I'm gonna take this little piece here and we put it down by the chart so we could easily see on for the rest of our points. Right? So 3.5 and 7. Then we did 4.4 and 25. You see there? Then 5.3. Right? So 5.3 would be, this is 5 in the middle here. So 5.3 is 1, 2, 3. This line here is 5.3. So we're doing 5.3 and 55. This is 50, this is 40. So 55 will be somewhere in the middle here. Right? So check me out here. Second line. So 1, 2, talking about somewhere right here. See that? Then I'm doing 6.2. 6.2 would be this line here. And 84. 84 easy because you're counting in twos. So right here. All right, then I'm doing 7.1. This will be 7.1 here. 5.3. 6.2. 7.1. And 112. 110. 112 will be this line here. 7.1. Right there. And then finally 8, which will be here. And 120. There. See that? And then we draw a nice smooth line connecting all the points. That's the cumulative frequency curve. The more thumbs up if everybody understand that. Right now, we look this afterwards, right? Look at this part of the video and look at what I tell you about this. This is a nice question because it's showing you step by step how to draw a cumulative frequency curve. Right? Use your diagram to find an estimate for the median mass of the newborns. Well, the median mass, right? If you look at you have to look, that would be the middle number, right? Middle number. So basically, you're looking at, you have 120 of them. You're looking at the middle number. So to use the graph to do that, we would just simply draw a line on our graph. Just get more ruler. Right now, the total cumulative frequency is 120, meaning that the total number of babies is 120. So 120 divided by 2 means that we're talking about the 60th position. Where's 60? 60 is here. And we draw a line coming down now. So that's roughly 5.6. Right, so this is the total frequency divided by 2. That's how you're going to find the median position. Median position is the sum of the frequency, the total frequency divided by 2. 120 divided by 2 is the 60th position. We go to our graph. We find where 60 is. We draw a line to meet our curve. And then we draw a line coming down. right? This is 5.6 kgs. Everybody good with that? Right? Now, depending on how you draw the graph, it will have a little range, right? So some people might get 5.6, 5.5, 5.45, right? Anywhere around that vicinity would work. Cool. Everybody okay with the statistics question? Right, we have our one. Let's see what we could do again. Right, so we're going again. Diagram below shows a hemispherical bowl and cylindrical tin. The diameter of the cylindrical tin is 12 centimeters and the height is 17 centimeters and the radius of the bowl is R. Show that the volume of the cylindrical tin, now volume is always area multiplied by height. Here we have a circle, so the area of a circle is pi r squared and we have the height, right? Show that it is 1923 centimeters cubed to 4 significant figures. The diameter is equal to 12, so the radius is 6. So the volume is equal to pi, if you take pi to be 22 over 7, multiplied by r squared, which is 6 squared, multiplied by the height of 17. We go to our calculator. 6 squared is 36 by 22 by 17 divided by 7. That is 1923 centimeters cubed to 4 significant figures. The exact figure 4285. Right, this is the exact figure. So the 4 significant figures will be 1923. The bowl is completely filled with soup. When all the soup is poured into the empty cylindrical container, it covers 90% of the volume of the tin. Now, when you read things like this, what is 90% of the volume? We just said that the volume is 1923 to 4 significant figures. So 90% of that 0.9 multiplied by 1923 is 1730.7. So the volume, therefore, of the bowl is 1730.7 centimeters cubed. Right? They say a volume of a sphere with radius r is 4/3 divided by 2. But a sphere is not a bowl. So a volume of a sphere, or we could say the volume of the bowl, is going to be half the volume of a sphere, because the bowl is not the whole thing, it is half. Understand now? Give me a thumbs up if you agree with that. So a half by 4/3 pi r cubed. We can record that, right? Because now we cancel this here with this here. So you get 2/3 pi r cubed, right? Now we don't know what the radius is. But we know the volume is this. So what we're going to do, we can move this 2/3 first. If I move that 2/3 first, I will get 1730.7 divided by 2/3. Because it's multiplying here, when I carry it across, it has to divide. Right? I leave this here for now and deal with what we have on this side. So 1730.7 multiply now and flip that fraction. Right, what will you get? Calculator 17.30.7 by 3 divided by 2. You get 2596.05. 2596.05. The next thing is this pi, which is 22 over 7. Right, pi is 22 over 7. So now we have our next one of them things to do. We had to divide now by 22 over 7. And we know when we're dealing with fractions and we're dividing, this had to change to a multiplication. I had to flip this. And what are we going to get? 2596.05 multiplied by 7 divided by 22. That's going to give me 826.015. The last thing I have to do now is come and find the cube root of this figure. Why? Because I'm moving this cube across the equal sign. Now, even though I write in this on my calculator, I have a longer value. So that's what I'm finding the cube root of. And that's going to give me 9.38. Just double check to see if they tell you write it to any specific value. No. All right, we put it to 2 decimal places. And this is in what unit? Centimeters. Everybody okay with that? More thumbs up if you understand what happened there. Yeah? Good. Right. Let's move on. In the diagram below, points L, M, and N are on the circumference of a semicircle. The radius is 18 centimeters. Calculate the total area of the shaded section in the diagram. Okay, so that's going to be the area of the semicircle minus the area of the triangle. Everybody agree with that? Or you want to join it there? Right, so everybody agree that to find the area of the shaded section, we find the area of a semicircle. So the area of a semicircle is just half the area of a circle, right? Pi r squared, and we find half of that. So that straightforward. A half 22 over 7 multiplied by the radius, which is 18 squared. The area of the triangle now, the base, this base here is going to be what? 18 and 18, which is 36 half by 36 by the height. The height is also 18 because look at it. This is a radius. See that? Everybody see that? More thumbs up if you see that. The base by height. So let us work that out. So easy, guys. So 18 by 18 by 11 divided by 7. This side, half of 36 is 18. You get 18 by 18. 224. So 519.142.857 minus 324. 185.14. Easy? Everybody okay with that? Don't give up marks on these questions, eh? Take your time, read the question, and then execute. Right, this one now. Diagram below shows the first 3 shapes in a sequence, which forms a pattern. Each shape is made using a set of small white counters and black counters. Complete the diagram below to represent the 4th shape. So they just keep adding the counters on the outside and along the side. So this is what the shape would look like. Right, so add another row on the outside here and one on alongside that. Right? Basically what I'm saying is that you're adding a row here. And you add a row coming up here now. Right, 5 there and 5 on the side there. Right, before you had 4 and 4. 4 and 4. You seen it? 1, 2, 3, 4. 1, 2, 3, 4. So now you're doing 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Everybody see now? Right, so this is the new sheet. Everybody good with that, right? I'm going on. So look what happening here. And each time we come down, this is going to become 4 plus 1 squared. That's what? 25. Right? So basically is if we have if this is n, then we're doing n plus 1 squared. Right? The values that we get in here will be 3 plus 1. Right? The 1 is constant. Look at what being constant. Right? And then there's always 2 multiplied by the n. So n plus 1, right? 3 plus 1, 2 plus 1, 1 plus 1. So it's n plus 1. Then we're going to have here 2n, right? Because we do 2 by 3, 2 by 2, 2 by 1, plus 1. See that? Everybody see now? Give me a thumbs up if you see now. Right. And then look at what happened here. 6 plus 4 is given me 10. 15 plus 9 is given me 24. 28 plus 16 is given me 44. So 45 and 25 will give me 70. Yeah? Everybody right to that? So 144 means that we take this and we're trying to work backwards. That would mean that I had to square 12 squared to give me 144. right? We know inside of here have to be something plus 1. So 12 minus 1 will give me 11. So I know this was 11 plus 1 to come up here to give me 12 squared to give me 144. Agreed? Tell me if you agree with that. 11 plus 1, 12 squared to give 144. Everybody agree with that? Right. So it means that this is my n. Right? This is the shape number 11. And then if you go in according to the shape number, this will be 11 plus 1, right? And then 2 by 11 plus 1. So this is 12. 22 plus 1 is 13. $156. Everybody all right with that now? My thumbs up if you understand what we did in that table. Good. Right, so I'm pressing forward again, right? The expression for the total number of counters in shape S is given by this formula here, where A and B are positive integers. By substituting suitable values for S, show that the total number of counters in shape 1 and shape 3 in the terms of A and B is represented by the equations, right? So remember, this is the equation that we have here. In shapes what they want, right? In shape 1 and shape 3. A plus B is equal to 8. Okay, look at this. Total is white plus black. White plus black. So they're saying that show that A plus B is equal to 8. And 3A All right, so look at this, right? Remember, this value for T is given by this formula here, right? So T is equal to 3n squared plus 5n plus 2. They want us to show that the total number of counters in shape 1 and shape 3 in terms of A and B is represented by those equations. So what we have to do is the A and B are really the coefficients that we have in front of this quadratic here, right? Remember, our quadratic is in the form a squared plus bx, ax squared plus bx plus c. So the value of this plus this is equal to 8. The A and B is going to be equal to 8. Now, 3n squared plus 5n plus 2 in shape number 1 is equal to how much, right? 10. See that? Everybody understand that? This here, which is the general formula for T, is equal to 10. Give me a thumbs up if you understand that. So we want to find the values of A and B, right? For when this is equal to 10. Now in shape 1, remember, This here n is a shape number. In shape 1, n is 1. So 3n, 3 this squared plus 5 by 1 plus 2, right, is equal to 10. Everybody agree with that? Right. So instead of, and while this is a general formula, when I do in shape 1, they want to know what values by the n, they say a and b. Remember I was telling you that this and this is a and b. What are the values multiplied by this 1 is going to give me 10. You want me to show that? You want me to show that a plus b is equal to, so this will give me a plus 1 squared is 1. B by that will give me 1, b plus 2 is equal to 10. So a plus b is equal to 10 minus 2. And a plus b is equal to 8. So we just show that a plus b in shape 1 is equal to 8. Let us look at shape 3. In shape 3 now, n is going to be 3. Formula is an squared plus bn plus 2 is going to be equal to what now? Shape 3 was 44. And then these values of n are going to be 3. So we get 9a plus 3b is equal to 144 minus 2. So 9a plus 3b is equal to 142. Well, we could divide here by 12 by 3, 5 and 2, 7. What you want? 14. Not 144. This is 44, man. Right? If you divide by 3 throughout, you're going to get 3a plus b is equal to 1 for 14. Right? So we just prove that these shapes can be represented by these equations. Everybody okay with that? Yeah? Everybody all right? Ready for section 2 now? And them thumbs up coming in slower and slower. So you're too tired. Everybody all right? We continue. Raise your hands if we could continue. Good. All right. Everybody did. Nice. All right. So next one. The diagram below shows the equation. The diagram below represents the graph of two functions on the same pair of axes. The lines G and H are perpendicular. Right now, perpendicular lines have a gradient, right? That is always equal to -1. That's the difficult way of doing it. But if two lines are perpendicular, let's say I have a line 2x plus 1. The other line that is perpendicular to this, the gradient is going to be the inverse of this. It'll be negative, and you always flip the fraction, flip the number. So this will be the gradient of a perpendicular line to this line here. Everybody understand that? Anytime you have two lines and they're perpendicular, the gradients of them, the gradient of the perpendicular line is going to be the negative inverse of the number. Understand? Not thumbs up if you understand that. Right. So let's look at some points that we have here. This point is the point -60. This is another point here, 0, 3. Right? So this is on the line G. So if we want to write the equation for the line of G, what we need to do first is find the gradient. Gradient will be y2 minus y1 over x2 minus x1. We have 2 points. We have -60 and we have 0, 3. This is x1, y1, x2, y2. 3 minus 0 over x2 is 0 minus -6. That is going to give me 3 over +6 because our minus by our minus is our plus. So my gradient is a half. Now the line, equation of the line is y is equal to mx plus c. Right? You can take this point here is the point when x is equal to 0 and y is equal to 3. Now when x is equal to 0, and we have a gradient of a half, x is 0, and this value for y here will be 3. What will happen is that you will get a half by 0 is a 0, and c plus 0 is c, right? So the value of c is 3. So it means the equation of the line is going to be y is equal to a half x plus 3. Gradient is a half. Here we found the value of c. By substituting these 2 points into the equation where we knew the gradient after calculating it out was a half. Anybody understand that? No thumbs up if you're okay with that. Anybody do understand? Just raise your hands. So my steps when I'm finding the equation of the line is 1 for the steps. We need to find the gradient. Gradient is y2 minus y1 over x2 minus x1. Secondly, you're going to substitute the gradient, wherever you get for the gradient, into y is equal to mx plus c along with coordinates from 1 point to give you x and y values. So that's what happened here, Solana. We found the gradient first. We write the equation of the line. We substitute a half inside of here. And then we take one of the points to get a x or a y and a y value. Y is 3, x is 0. We're doing that in order to find what c is. Because to write the equation of the line, we need to know what m is and we need to know what c is. You understand that now, Solana? Right? So that's what happens anytime we're trying to find the equation of the line. The equation that represents the line H. So H is perpendicular, right? So that means the gradient is going to be -2. Inverse of the negative inverse of the other gradient. So we need to find y is equal to mx plus c. So we need a point on the line. We go back here. A point on the line H is this point here. At this point, y is 0. Sorry. X is 4 and y is 0. If we substitute y to be 0, the gradient is -2, x is 4, you get -8. Right, we find for C. Carry the 8 across, it become positive. Now that we found for C and we know what M is, the equation of the line is going to be -x, -2x plus 8. Everybody understand now? Now thumbs up if you're okay with that. Anybody not clear now? Good. All right. Coordinates of the point P. The point P is where the two lines intersecting. Anytime two equations intersecting at a point, all you're doing is you're taking the two equations. You have y is equal to -2x plus 8, and you have y is equal to 1/2 x plus 3. You want to find the coordinates of the point. This is a point of intersection between two lines. Make sure both of them written in the form y is equal to mx plus c, and then you equate each other. You equate them to each other. You put this to be equal to this, and you solve for x. After you get x, you could find out what y is by substituting the value for x into any one of these. So check this out. To make life simple, I'm just gonna multiply this whole thing by 2 so I can get rid of this half here, right? So I get 4x plus 16 is equal to x plus 6, right? I could do -4x on this side, bring this x across here, become -x. Move this 16 here, become -16 plus 6. Again, minus 5x is equal to -10. X is equal to -10 over -5. X is equal to 2. When x is equal to 2, y is equal to, I'll use this one, 1/2 by 2 plus 3. 1/2 of 2 is 1. 1 plus 3 is 4. So the coordinates are P. P is equal to 2, 4. Everybody all right with that? Right, so it's like a simultaneous equation, pretty much. All right. This one. Some of values. A is 4. B is -24. C is 31. Picking up from here. H is equal to B over 2A. And K is equal to C minus A by B over 2A squared. H is equal to -24 over 2 by 4. It's -24 over 8, -3. K, 31 minus 4 by -3 squared. 31 minus 4 by 9 right? That'll give more 31 minus 36 minus 5. So 4x squared minus 24x plus 31 is equal to 4 into x, h is negative 3, and k is negative 5. See now? Everybody okay with that? Good. Now, on the axis below, indicating point, it's a maximum and minimum point. So, because this is 4x squared minus 24x plus 31, and this value is positive, it will have a minimum turning point. So that mini graph going to look like this. It's going to look like a smiley face because it's positive. Positive means that you get a smiley face. Negative, frowning face. The turning point going to occur at negative h and k. So what is negative h? H is already negative 3. So negative, negative 3 will give more and what's k? Negative 5. 3 and 5. Negative 5. So I put 3 somewhere here and negative 5 here. So this is where the curve going to come down to and stop, right? Now, this is for the turning point. The next thing we need to do is the y-intercept. Y-intercept is when x is equal to 0. Now, y is equal to 4x squared minus 24x plus 31. That's a graph, right? All of these graphs and lines and things is always y is equal to some equation. So when x is 0, if I put x to be 0 inside of here, I will get 4 by 0 squared minus 24 by 0 plus 31. Agree? And anything by 0 is going to be 0. So it means that y is going to be 31 when x is 0. So this is where x is 0 here, right? Because this is where x is 3, here is 0. So it means that there's a point here where the curve is going to pass through and cut this y-axis. So if we have to draw this curve is actually going to cut through here, come down here, reach to this point, and then come back up this way. The equation of the axis of symmetry is a line that could be drawn coming down here that is going to divide the curve into 2 equal parts. And we will usually get the equation of the axis of symmetry from this part here where we have x plus h. So for the axis of symmetry, watch this. Axis of symmetry, anytime we tell you find the axis of symmetry, if we take this x plus h and put it equal to 0, and x is equal to negative h. So in our particular thing here, we have x minus 3 is our x plus h. So we're going to get x minus 3. Put that equal to 0. Carry the 3 across and we're going to get positive 3. This is the equation of the axis of symmetry. It's a straight line cutting the curve into 2 equal parts. Everybody okay with that? Raise your hand if you're not okay with it. Right, so important things that you need to take away from this question. These formulas here for h and k, important, right? Remember when you have to write it in this form, that's how you're getting the h and the k values. Sketching our graph. You need to find the y-intercept and the turning point. The turning point is minus h and k. So whatever value you find for h, you put in a minus sign in front of it. And whatever value you find for k, that's what's going to give you a turning point. That is either the bottom of your graph or the top of the graph. It depends on whether this number in front of the x squared is positive or negative. If it is positive, it's going to be at the bottom. If it's negative, then it's going to be at the top. It'll be a frowning face. Understand? More thumbs up if you understand that. The axis of symmetry is always this middle portion inside of the computed the square area. You're taking this, putting it equal to 0, and you're carrying the h across the equal sign. And this is what you're going to get. X is equal to something. Always x is equal to something. Because it's going to be a vertical line coming down through that number that x is equal to. Okay? Everybody good with that? Let's see what we can do here. Almost done. All right. They want us to find the value of the angle KOL, right? KOL. Now, KOL is at a 90-degree here, is also a chord. Right. So look at this. KO is meeting here at a 90-degree angle. Agreed? We know what this is. We know what this is. So for this little angle inside of here, it's going to be 90 minus 12 plus 48. 90 minus, that's what, 50 and 10, 60. So that's 30 degrees. So it means that this little angle here is 30 degrees. Give me a thumbs up if you're okay with that. So if the angle is 30 degrees, it means that from here to here is 30. And from here to here will also be 30. Right? So we have isosceles triangle because this is two radius here. And 30 and 30 is 160 is 60. So we have 180 minus 60 is going to give us 120. Right? This is KO meets tangent at 90 degrees. Angle MKL is equal to 90 minus 12 plus 48, which is equal to 60. Then we have triangle KOL is an isosceles, since ends of chord KL extended to center O, making these angles equal. Angles in triangle, sum of angles equal 180. So KOL is equal to 180 minus 30 plus 30. Okay? L, M, L, M, N. L, M, where N? Okay. So this is the opposite angles in your cyclic quadrilateral. Right? They're supposed to sum up to 180, is it? Opposite angles in your cyclic quadrilateral. We could either do that, or we could also look at that's not. This is not it. This is not just 30, again. This is 42. How much I tell you? Right. I'm making a mistake here. The angle here is 30. I myself tired. This here is 30. This whole thing here is 42. So this whole thing here is 42 as well. So 42 and 42 from 180. So 180 minus 84. 6. Remember 90. 96. 96 degrees for the middle angle, right? Not 120. Check something, eh? Watch. I send some of these things here, right? Everybody with me so far? Right. Look at this. This and this, same base. Watch out this triangle here. This triangle here. And watch this triangle here. Both of them on the same base. This is the angle at the center. And this is the angle at the circumference. What's the rule for the angle at the center, the circumference? This is going to be, at the center is twice the angle at the circumference. So if this is 96, it means the one at the circumference is going to be how much? 48. LMN is going to be 48 degrees. Angles at the circumference is twice, is half. The angle at the center when subtended on same arc, right, or chord. All right, angle KLO, KLO, that's KLO there. Yeah, we recorded already. That angle was 42 degrees. Right, this angle in isosceles triangle equal KLO is equal to OKL or MLK. No, OKL. OKL. Angle MLK now. MLK. But we will call this one just now to be 30. This is 46, we say it was, or 48? 48. So this one at the bottom is going to be 180 minus 30 plus 48. So that's 180 minus 78. Yeah? $102. And last one, angle KNM. KNM. This one here. Right, so we have an angle on the tangent and on the opposite side. Or we could use the cyclic quadrilateral. What you get for this angle here? 102. Here's 102. The two opposite angles in our cyclic quadrilateral had to add up to 180. So we could do 180 minus 102. 78 degrees. Opposite angles in cyclic quadrilateral sum to 180 degrees. Okay. Everybody all right with these solutions here for this question? Yeah. All right, guys. So I'm gonna have to wrap up because I have to have an appointment. I have an appointment to go out for 3 o'clock. So I can't stay on any longer, unfortunately. I'm going to send you these solutions. Just stop the recording.